So I got this email from viewer. The title says, please try out this Cambridge Step 1 question. And the email says, I would love if you make a video on this question that fully tests your understanding of Calculus 1, differentiation, and integration. Okay, so let's have a look. This question has 5 parts, and I think they are really interesting, so here's the deal. First, we're given 2 functions, s and c, and we know that s of 0 is equal to 0 and c of 0 is equal to 1, and we also know their derivatives. S prime of x is equal to c of x squared, and then c prime of x is equal to negative s of x and then squared. So this really caught my attention because I think you will be thinking the same thing too. Is s kind of like the sine function and then c like the cosine function? Well, not quite, right? Because the derivative of sine is not cosine squared. So, interesting. But anyways, we're just going to follow the definitions and then do the questions and see what happens. Part 1. We are going to investigate s of x to the third power plus c of x to the third power. We want to make sure that it's actually just a constant function and that constant is equal to 1. To do so, we can actually just take the derivative and then check if the derivative is equal to 0 for all x. If so, then that means it's just a constant function, and then later on we can plug in the x value to figure out what that constant is. So right here, power rule in action, bring the 3 to the front, and then subtract 1 to the power, and then right here use the chain rule, so you multiply by s of x. Continue here, put the 3 to the front, and then subtract 1, and then here we multiply by the derivative of c of x, so that's c prime. Now this and that are given, so we can just plug in. So here we have 3 times s of x squared, and this is just c of x squared. Continue, plus 3 c of x squared, and this is negative, so multiply by negative, and then s of x squared, like so. Now, as you can see, this term is positive, this and that are the same, and that is the negative term. So all in all, this is equal to 0, and we can say that's true for all x as a real number. So that means our expression s of x to the third power plus c of x to the third power is a constant for all x. I'm just going to write it like this. Now, to figure out what the constant is, just go ahead and pick an x value. Here, we're given when x is equal to 0. That's the only number we can use. So let x equal to 0. Then we see that s of 0 to the third power plus c of 0 to the third power. Well, this is given, which is 0. And then this right here is given, which is 1, which is equal to 1. And since when x is equal to 0, this expression is equal to 1, and this expression is a constant, that means, I'm going to just write it down right here. Therefore, s of x to the third power plus c of x to the third power is equal to 1, and now I'm just going to put for all x. Right? So that is part 1. Now for part 2, it actually has 2 parts. The first part of part 2 is that we are going to differentiate s of x times c of x, and they gave us that we should end up with this expression, so we'll just go ahead and supply the steps. And then the other part is that we will differentiate the quotient of this instead. So anyway, so have a look. For this right here, I'm just going to use the product rule, so I'm going to keep the first function times the derivative of the second, which is c prime of x, and then I add the second function times the derivative of the first. Okay, and then right here, this is still s of x, but this is that which is negative s of x squared, and then c of x stays. Okay, and then this right here is given, which is that, and perhaps I will just keep the color the same. This right here is still c of x, but this right here is c of x squared. Okay, and then as you can see, this right here is negative, and then one of this times two of them, so it's s of x to the third power, and then that's another third power, right? Okay, so what can we do right here? Well, we have the third power, so we can just use what we did earlier. So from part 1, so note that s of x to the third power plus c of x to the third power is equal to 1. So have a look. We want to end up with an expression in terms of c of x. So that means I want to isolate this. So that means s of x to the third power is equal to 1 minus. I think this is a really creative question because, yeah, it's totally just like another version of sine cosine business, right? Same thing, seriously. Okay, and then I'm just going to put this into there and then just do the work. So not so bad, I will say. And then let's see what do we have. This is equal to negative parentheses and then 1 minus c of x third power. Yeah, and then plus c of x third power. Okay, and then distribute. So if you distribute, of course, you just get negative 1. And then you get positive c of x to the third power. So combine this and that, we have a total of 2 of them. Third power and then minus 1. So that's it. When you multiply this and that and take the derivative, we get that. Now let's do the quotient. So now, quotient rule, and we are going to get the following. I'm going to square the denominator, so c of x, and I'm going to square that, and then I'm going to put the bottom function here, and then we multiply by the derivative at the top, which is s prime of x, and then we subtract the top function, and then times the derivative at the bottom, so c prime of x. Okay, and then just plug in the usual things, right? So c of x, this right here is given to be that, so it's c of x, and then squared, and then minus, this is s of x, again still keeping in red. And this right here is that, which is negative, and then s of x squared, and then yeah, and then all over c of x squared. And then have a look though, this times that is plus, so on the top we actually just have c of x to the third power and then plus s of x to the third power all over c of x squared. And remember from what we did on part 1, this thing here is nicely equal to 1 from part 1. And that is just going to give us 1 over c of x squared. And then I think this is it. We're done. We want an expression in terms of c of x. So that's part 2. Now for part 3, once again we have 2 parts. The first part is that we are going to integrate s of x squared, and this is not so bad because we know that c prime of x is equal to negative s of x squared. So have a look. I'm just going to rewrite it as integral, put a negative to here, and then I still have c prime of x. Yeah, and then dx. And then of course we can put the negative on the outside, and then integral and derivative pretty much cancels. So we have c of x, and then we're done. And we use c for the function, so I'm not going to put down plus c, even though I told you guys don't forget the plus c. But here I'm going to put down plus k. And then right here, I'm just going to say, hey, this is our constant, arbitrary constant, whatever, all right? So this right here, we'll do it. Now for the second integral, we are going to integrate s of x to the 5th power. So this right here, seriously, just think back about how you will do like a sine to some power integral. In this case, because we have the second power, right? So I think it's a good idea to like break it down into the 3rd power times the 2nd power. So I'm going to just write this as the integral of s of x to the 3rd power times s of x to the 2nd power. So remember, if we have the s of x to a 2nd power on the outside waiting for us, then inside here we should have the c function, right? Well, what can we do? Well, again, when we have the 3rd power, remember that this part, we know from part 1, s of x to the third power plus c of x to the third power is equal to 1. So I'm just going to put this to the other side. So this right here is equal to integral, and then I'm going to write it down as 1 minus c of x to the third power, and then here we have the s of x squared and then dx. Okay, then we are going to do a u substitution. I'm going to pick this right here. It's very nice. So I'm going to say that u equal to c of x. Just think about this as like a cosine function, something like that, but it's not cosine, c. Anyways though, du is equal to c prime of x dx, and c prime of x is precisely that. So we know that's negative s of x squared dx. So have a look. If we want to take this integral to the u world, this is positive. Well, we want negative, right? It's okay. I'm just going to multiply this by negative and put a negative on the outside. We'll do the cancellation, depends on how you want to do it. I'm going to just make it more clear by isolating the dx. So as you can see, dx, it will be equal to du over this thing. Negative parentheses s of x squared. Okay, so this right here is equal to the integral 1 minus u to the third power, and then this right here is still s of x to the second power, and this is that. So du over negative s of x squared, and this and that cancel, and a negative on the outside. So we have a negative, and then I'm just going to put down the parentheses for the result of the integration. Integrating 1 in the u world, we get u, and then integrating u to the third power in the u world is 1 over 4 u to the fourth power. And I'm not going to put down the plus k yet. I will just do that at the very end, because I still have to go back to the x world. Distributed, we get negative, and then the u is c of x, so negative c of x, and then plus, and we have 1 over 4 c of x to the fourth power, and then right here at the very end, we're done. So put on the plus k. That's it. Now for part 4, it gets really interesting. We'll be integrating 1 over 1 minus u to the third power in the parentheses raised to the 2 over 3 power, and here they gave us the answer, which is the inverse of s of u. So here we are given that the function s has an inverse. So how do we do this? Well, just think about the usual trig substitution. Here though, we are going to have the u, and notice we also have this relationship, so keep that in mind. First, let's just take u to be s of x. In fact, it was given on the test as well, but we have to know the rest. Usual business, differentiate that, we get s prime of x, which is going to give us that. So that's c of x squared dx. Now, I'm going to take this integral from the u world to the x world. So this is the integral 1 over 1 minus u is s of x. And then here we have that to the third power. And then raise that to the 2 over 3 power. And then du is all that right here. So c of x squared dx. Now, we can actually simplify this pretty nicely, because this inside here, if we put this to the other side, we'll just get c of x to the third power. So this is c of x to the third power in blue. And don't forget, we still have that raised to the third power. So of course, you can just multiply the powers. So in fact, we have c of x squared on the bottom. So this right here gives us integral 1 over c of x to the second power. But here we are multiplying by c of x to the second power dx. And ladies and gentlemen, have a look. Wow, they cancel. And then right here, we're just going to have integral of 1 in the x world, which will just get x. But no, it's not the answer yet, because we have to go back to the u world. Right? This is very different than the ones that we usually do, right? We want to go back to the x world and we x. No, we started with u. Here we have x. We go back to the u world. How though? Well, we use this relationship. So note that we know u is equal to s of x, and we know that it was also given in the question, s has an inverse. So we know if we take the inverse on both sides, that will give us inverse s of u, which is root x. So that's what we have to do. The x here, write it as inverse s of x. And then finally, we can just put down plus k for the constant of an integration, and that's exactly what we have right here. Yeah, then let's move on to the next one. Now, question for you, how many parts are we going to have for part 5? Well, if you answer 2, then you are correct. This is just the first integral for part 5. We're going to integrate this thing, and this time we don't have the answer, but it's okay. It's pretty much that what we did earlier. So notice that u to the third power, I'm going to put u to be s of x, and then do the usual business. du is equal to this derivative, which is just that, so c of x squared dx. Now, going to the x world, we will have the integral 1 over 1 minus parentheses s of x third power, and then here raised to the 4 over 3 power, and du is this thing, so c of x squared dx. Now for this, just like what we did earlier, use this identity, put that to the other side, we get c of x to the third power, and then go ahead, raise that to the 4 over 3 power. So the denominator is just 1, well, the denominator is just c of x to the 4th power, right? Multiply the powers, and then here we have the c of x squared. And then we can cancel 2 of them, like this. So this right here gives us integral 1 over c of x, and then square dx. Alright, so that's pretty good. Now, how are we going to integrate this though? The key is that we have to use the result from part 2. We know the answer. This right here is actually just s of x over c of x, and then plus k, but I'll write it down later. The reason is because from part 2, we know that if we take the derivative of s of x over c of x, this right here gives us precisely 1 over c of x squared. So we're just doing it backwards. But remember, we still have to do what? Go back to the u world. So let's see. On the top, it's just u, so that's pretty nice. But on the bottom, how do we go back to the u world though? Well, we can look at this right here real quick. So we are trying to get c of x in terms of s of x. So right here, I'm just going to put this to the other side and then take the cube root to both sides. So you can see that c of x is just going to be the cube root of 1 minus s of x, and to a third power. And then this thing here is our u. So this right here, I'm just going to have over, and then I will have the cube root, and then 1 minus u to the third power. And then we're all done. So I'm going to put down plus k for the constant of integration. So that will do it. Now, the second part of part 5, we are going to integrate. Now for the second integral of part 5, we are going to do this one right here. Again, we'll use this special functions. So notice the u to the third power. So right away, I will just say u is equal to s of x, and then du is equal to this derivative, which is c of x, and then square dx. And then let's see what happens. So this right here gives us 1 minus s of x to the third power, and then to the 1/3 power, and then du is just that, so multiply by c of x square dx. Now, this portion again is c of x to the third power, and this time we're raising that to the 1/3 power. So for the first part, we just have the integral of c of x, and then here we have to multiply that by 2 more. So all in all, we are looking at integral of c of x to the third power dx. How do we do this though? Well, Oh, this is like the second power. Okay, again, you have to go back to what we did earlier. In fact, we are going to use the result from part 2 one more time. So I'm going to just make a note right here. Note. From part 2, we know that if we differentiate the product of S and also C, we get 2C of X to the third power minus 1. And now we are going to isolate this part. So add 1 to both sides. So we will get the following. C of X to the third power equals, here we have the derivative of S of X times C of X. And then I put the 1 to the other side already, so plus 1. But of course, we still have to divide it by 2, right? So I'm just going to have the 1/2 here, and then also the 1/2 here. Okay, so this right here gives us integral. I'm going to have 1/2 the derivative of C of S of X, C of X, and then plus 1/2, just 1/2. That's it. And then in the X world, like that. Okay. So to continue, we're just going to do the following. Firstly, we can put the 1/2 to the outside and the integral derivative cancel. So the first part is just 1/2 S of X times C of X, and then we are done. Now, next part, we have to integrate 1/2 in the X world. So we just need to say plus 1/2 X. Are we done? No, not yet, because we have to go back to the U world. So here we have the 1/2. S of X is our U. And then C of X is this thing. So I'm going to multiply the cube root of 1, and then that's minus U to the third power. And then plus 1/2 X. If you look at this, take the inverse of S to both sides, we get the inverse of S of U. So this is inverse S of U. And then we are done. So finally put plus K, and that's it. Yeah. Super fun question. So thank you, Mr. Kang, for sending me this question along with the solutions. That saved me some time. Yeah, anyways.